Good morning, my dear students. We are continuing the chapter called Units and Measurements, right? So, the name of the chapter, Units and Measurements. In this, today, we are going to continue the topic called Dimensionless Quantities and Dimensional Constants. What is that? We are starting with this topic, dimensionless quantities and dimensional constants. What is the dimensionless quantities? Already we have discussed angles. Any angle, it will not have any dimensions. Refractive index will not have any dimensions. Strain will not have any dimensions. Numbers will not have any dimensions. Numbers in sense 1, 2, it's 1 by 2. And even pi will not have any dimensions. So those are dimensionless quantities. There are so many other dimensionless quantities that will be discussed in the later sessions, because those are the physical quantities will not appear in units and measurements chapter, and those physical quantities you will be come across in the later chapters of first PUC and second PUC. That's the reason the basic some quantities only I had mentioned here. Come back to the dimensional constants. The dimensional constant, see, as its name indicates, it's a constant. We have universal gravitational constant. What is its value? A 6.67 into 10 raised to minus 11 Newton meter square per kg square. This is a universal gravitational constant. It will have dimensions. What is the dimension? We have already discussed and derived the dimension. F is equal to G m1 m2 by r square. From here G is equal to F r square by m1 m2. Force dimensions you know, distance dimensions you know, mass dimensions also you know, and you get the dimensional formula of this. That's called dimensional constant. And in the same way, speed of light. Speed of light. What is the speed of light in vacuum or in air? What is that? 3 into 10 raised to 8 meters per second. This is the speed of light. It's a constant in vacuum or air. This is constant, so that's called dimensional constant. What is the dimensional formula of the speed? You know, right? Speed is distance by time. So I can say its dimensional formula is LT minus 1. Alright. This is the basic thing about dimensionless quantities and dimensional constants. Now, the major topic for today's discussion is dimensional analysis. What is this? Dimensional analysis. Dimensional analysis and applications. Listen. Mainly, there are 4 dimensional analysis applications. Number 1. By using this dimensional analysis method, we can convert one system of units into other. We have SI system, we have a CGS system. From CGS to SI or SI system to CGS system, we can convert easily by using dimensional analysis method. And number 2, this is principle of homogeneity. What exactly meant by this principle of homogeneity? I'm just going to tell you, listen to me carefully. So this is used to check the correctness of an equation. In physics, you will be looking at you will be learning so many equations, whether the equation is correct or not. So this dimensional analysis will tell you. And number 3, this dimensional analysis will be used to find a relation among physical quantities. Relation among physical quantities. Alright. And number 4, this same dimensional analysis is used to design our own system of units. Let us discuss one by one. Before moving into the deep analysis, a brief analysis of these 4 applications, let's say. It's a method. Dimensional analysis is a method which is having 4 applications. What is the method? What are those applications? Let's see. First one. This dimensional analysis will convert one system of units into other system of units. We already know that. For example, look at here. 1 Newton is equal to 10 raised to 5 times. Yes or no? So this is the expression or an equation we can prove by using the first application of dimensional analysis. And principle of homogeneity, it is used to check the correctness of the equation. For example, let me give you an equation like V is equal to U plus AT. You know this equation, right? Whether this equation written is correct or not, the dimensional analysis will tell you. Understand? Now, used to find a relation among physical quantities. They'll give you the force, which is called centripetal force, or forget about the centripetal force, this is a force. Force is depending on mass and acceleration. That's it. The force is depending on mass and acceleration. How the force is depending on mass and acceleration? Force is equal to mass into acceleration. Look at here, there is a product between mass and acceleration. They will give you the force is depending on mass and acceleration. By using dimensional analysis, you can get a relation among these 3 physical quantities. Understand? Now, last one. Used to design our own system of units. For example, force dimensional formula is what? M L T minus 2. Understand? Because mass into acceleration, MLT minus 2. So this is the force. Always we will be representing in terms of mass, length and time. For example, if you feel bored by writing the force always into the mass, length and time expressions, if you want to write the force in terms of pressure, in terms of velocity, in terms of time, you can write. Understand? Force, you can write in terms of pressure, velocity and time. If you feel bored by writing always in terms of mass, length and time, you can do it like this. That's called designing our own system of units. In your SI system, mass, length, time will be there. But when we design our own system of units in this way, not only in this, right? This force can be written in any other three physical quantity forms. That also we'll be discussing now, right? I hope you got the basic understanding of dimensional analysis and applications and why we will be using this dimensional analysis. I hope you got the point. Understand? Clear? So be ready to start the first application of dimensional analysis called conversion of one system of units into other system. To convert one system of units into the other. All right. So a question will be asked in this way. Convert Newton into time, or the same can also be written 1 Newton is equal to dash time. Clear? Now, to solve this question, we are going back to the topic called any physical quantity denoted with the symbol Q can be written. It's a magnitude into a unit. Magnitude is denoted with the symbol N. Unit is denoted with the symbol U. I hope you remember the situation. Nu is equal to constant. This can be written as N is inversely proportional to U. From here, I can also write it as N1 by N2 is equal to U2 by U1. Again, N1 U1 is equal to N2 U2. This is the major relation we are going to use in this method to convert one system of unit into other system of unit. Majorly, we are going to use this relation. Are you ready? Let's discuss a little more about this equation. What is this equation? This equation tells that when the magnitude is increasing, the unit will be decreased. If the unit is increased means from centimeters to meter or grams to kilogram. Understand? When the unit is increasing and its magnitude will decrease. Okay, this we have discussed so many times in more detail. Remember this, N1 U1 is equal to N2 U2. So to solve these questions, we need to use this formula. N1 U1 is equal to N2 U2. N1, it's a value, 1 Newton. Understand? Here also some value will be there. Imagine that is X. We need to find that X. N1. So unit. Newton. Newton is the force unit. So here we are writing the dimensions of the force are M, L, T, right? Force dimensions. M, L, T minus 2. Okay. Which is equal to N2. Here it is also a value. a magnitude, a number, into dyne. Dyne is also a force unit. Force dimensions I am writing MLT minus 2. Is it alright? Now, carefully look at this. Most of the students do here, they cancel these two. But you cannot cancel because this is the unit. In SI system, this is CGS system. So that's why, for your better understanding, I am writing it is M1, L1, T1. It is M2, L2, T2. No confusions. Okay. Now, N1. N1 is what? Number 1. Into, we are writing units. Understand? This is dimension. We are writing units. So, mass unit in SI system. The left side it is SI system, right? Right side it is CGS. Understand? This is SI. Mass in kilogram into length meters into time second. Second minus 2, which is equal to, what is N2 here? Magnitude here. Right hand side magnitude. It is X into, this is CGS units. So we need to write the CGS units of here. Mass CGS unit is gram into length CGS unit is centimeter into time CGS unit is second minus 2. What is our aim? Our aim is to find this X value. Alright. X value let us find here. This X, keep it here only. This part you take it here. So that will be kg meter second minus 2 divided by this part I am just keeping here, gram centimeter second minus 2, which is equal to X. We need a number here. Second minus 2 cancel. Kg can be written as 1000 gram into meter can be written as 100 centimeters divided by 1 gram into 1 centimeter. Gram cancel. Centimeter cancel, which is equal to X. So finally tell me, what is your X value? X value is equal to 1000 into 100. So that will be 10 raised to 1, 2, 3, 4, 5. It's 5. 10 raised to 5. So this X value substitute here. What is the answer you get? 1 Newton is equal to 10 raised to 5 dyne. My dear students, this may be the first time you are learning this dimensional analysis. Let me tell you once again and let me explain in detail about the dimensional analysis, the first application now. Our aim is to convert one system of units into other. Question is, convert Newton into dyne. We know the answer. 1 Newton is equal to 10 raised to 5 dyne. We know. But still, we need to prove it by using dimensional analysis. 1 Newton is equal to X dyne. How much dyne? That X is the unknown. We know clearly that X will be the numerical, means a magnitude. So we have used the formula N1U1 is equal to N2U2. The history of the formula and the detailed analysis of the formula, again I had written here, you can go through that. N1 is the magnitude, U1 is the unit in one system. So that is the left hand side, which is SI system. N2 is the magnitude, U2 is the unit in the other system. That's called right hand side, it is CGS system. Alright. N1 into unit. It is what? Force. The quantity we consider as force. So that force dimensions I wrote here. N2 into unit. Force dimensions I wrote here. Both the sides force dimensions only we need to write, because we are converting the force units from one system to another system. But to avoid your confusion, what I did here, these units are different. These force units are different and these force units are different. So that is why M1 L1 T1 minus 2, M2 L2 T2 minus 2. What is this 1 and 2 represents? 1 represents it is left hand side SI system, 2 represents right hand side CGS system. But U1 is what? Unit. So that is why units I wrote here. Mass, kilogram, length, meter, time, seconds. In SI system. Mass, grams, length, centimeter, time, seconds. In CGS system. Alright. Clear? Then our aim is to find this X. What is this 1? In question itself it's given 1 Newton. See, 1 Newton is equal to X dyne. 1 Newton is what? Kg meter per second square. You got the point? 1 Newton is what? Kg meter per second square. So this is gram centimeter per second square. Now, so X value, if you divide this by this, you get X value. Here you see X value is 10 raised to 5. Understand? Now, the class work question. Class work, it's not the homework. Class work. In the same way, you need to write in detail from here to here. In detailed analysis I need. Question, example number 2. Convert joule into erg. Convert joule into erg. Or can also be asked, 1 joule is equal to dash erg. So this dash you can consider as X. That X is unknown. Find out X and substitute here and pause the video. Do this. A neat solution with answer. Send me in your WhatsApp now itself. Look at the second dimensional analysis application, my dear students. And this is called as principle of homogeneity. It states that, see, the quantities with same dimensional formula only can be added, subtracted, or equated. Remember how simple it is, you see. The quantities with same dimensional formula only can be added, subtracted, and equated. What about multiplication and the division? For the multiplication and division purpose, the quantities may or may not be having the same dimensions. Multiplication and division purpose, the quantities may or may not be having the same dimensions. Clear? With an example, you'll understand it far better. Let's see. The quantities with the same dimensional formula only can be added, subtracted or equated. For example, look at here. X is equal to y plus z. This is an equation. What is that? This is a given equation. Look at here. So this is the given equation. A physical quantity. It is a physical quantity and z is also a physical quantity. According to principle of homogeneity, these two quantities are adding, right? Immediately you should write the dimensions of the y definitely will be equal to the dimensions of the z. Understand? Clear? Now, this is the quantity is equal to this quantity plus this quantity, right? The quantities with the same dimensional formula only can be added, subtracted or equated also. In the case of equation, listen, if this is the force dimension, force, if that quantity is a force, this also will be the force, or at least the dimensions which are same as force. This also must have the dimensions of the force, right? So that is equal to x also. That's a rule of principle of homogeneity. In simple words, how many physical quantities are there? I'm talking about how many physical quantities are there in the left hand side of the equation. Those dimensional formulas must be equal to individually how many physical quantities are there in the right hand side. Another equation, let me write another equation. If I write a plus b is equal to c minus d. Okay, first thing, we are doing addition here. To add two physical quantities, their dimensions must be same. So I can clearly write a is equal to b dimensions. To subtract two physical quantities also, their dimensions must be same. So I can write c is equal to dimensions of d physical quantity. According to principle of homogeneity, equated is also included. Then I can say what I told you just now. Left hand side, how many physical quantities are there? A. That must be equal to this b dimensions. That must be equal to this c. That must be equal to this d dimensions. Is it clear? For the multiplication and division, there is no condition at all. You can divide the force divided by velocity. Dimensions of the force by dimensions of the velocity. This we had already done. So let me tell you. F, dimensions of force mlt minus 2. And dimensions of velocity, it is lt minus 1. These two can be divided. F by v, dimensions of force by dimensions of velocity, mlt minus 2 by lt minus 1. L gets cancelled, it will be mt minus 2. And this is minus 1 goes up, that will be plus 1. So mt minus 1. Is it okay? So dimensions of the force you can divide with the dimensions of velocity. Understand? In the same way, you can multiply also. You can multiply the dimensions of, you can say the dimensions of acceleration, lt minus 2. You can multiply with time dimensions, t. So what is acceleration into time dimension here? So this is lt minus 2 into t. So that is lt minus 1. So this is dimensions of acceleration into time. See, dimensions of acceleration into time. You got this? So there is no rule for the multiplication and division of the quantities. But when we're doing it this way, addition, subtraction or equation, so principle of homogeneity must be applied. How the numericals will be asked. Let's see. Example. V is equal to U plus 80. This is the equation they mentioned. The question is, please check the dimensional correctness of the given equation. Whenever you say the dimensional correctness of the equation, the first thing it should come to your mind is the principle of homogeneity. What is this? The principle of homogeneity. Alright? According to principle of homogeneity, we have this V is equal to U plus 80. When there is an addition is going on between these two, so this is U and this is 80. So these two dimensions must be same. So what I can say, dimensions of U must be equal to dimensions of 80. Understand? Because addition is going on in between those two quantities. According to principle of homogeneity, this V is also equal, must be equal to these dimensions or these dimensions. That's what we discussed here. Left hand side, how many entities are there? It's not about quantities, because sometimes the quantity may be the product of two different quantities. That's why it's easy to remember. Left hand side, how many entities are there individually? Only one entity, V. Right hand side, how many entities are there? 1 and 2. So the dimensions of this entity must be equal to the dimensions of this. That must be equal to the dimensions of this. So that's it. If it is satisfied, then you can say this equation is dimensionally correct. Let's check. Velocity dimensions. What is the velocity dimensions? Lt minus 1. What is AT dimensions? AT. A is the acceleration, Lt minus 2, and T. So if you solve this, you will get it as Lt minus 2 plus 1. So can I say it is Lt minus 1? This is finished. And this is also final velocity, right? Final velocity dimensions are Lt minus 1. See, dimensions of this is equal to dimensions of this is equal to dimensions of this. So we can say that this equation, the given equation, is dimensionally correct. The given equation is what? Dimensionally correct. You understand? Really? Now. So another classwork I am going to give you now. Listen. We know, here I can write, S is equal to ut plus half at square. Check the dimensional correctness of this equation. And v square is v square minus u square is equal to 2as. Check the dimensional correctness of this equation also. My dear students, it's not a difficult task. Follow this. I will give you the hint also. The question is, check the dimensional. So you need to send me the WhatsApp picture by pausing the video in this way. In this way. Right? Check the dimensional correctness of the given two equations. What you need to check? In the first case, you need to check this one. Dimensions of the displacement is equal to dimensions of the ut is equal to dimensions of, see, anyway, half will not have any dimensional formula. Dimensions of AT square. Prove whether it is true or not. In the second case, dimensions of V square is equal to dimensions of U square is equal to dimensions of ES. Prove it by writing the dimensions of displacement, velocity, time, acceleration, time, velocity, acceleration, displacement. Okay, this will be the classwork. Get ready for your assignment of 10 questions. All the very best.